Hi, welcome back. In this session, we are going to discuss about the aggregate functions in NumPy. So aggregate functions is nothing but getting a single numerical output from n number of numerical elements. For example, we have three digits, three numbers, 2, 4 and 6. We can take the sum of all these three numbers, that is 12, which is a single output, but it is involves all the three numbers. So that is one of the simplest example of an aggregate function, or we can say the average of these three numbers, or the maximum or minimum of those numbers, because maximum minimum, even though it's a single peak from that group of elements, still it involves the whole set of numbers, because we can't count a maximum without having 2 and 4. The output 6 cannot be without 2 and 4. Similarly, the count is also one of the example of an aggregate function, because the number of elements there is 3, that involves the whole every numbers, but the output is a single digit. So let's start by importing the NumPy library, import NumPy as NP. And then I created a NumPy array of shape 2 by 3 by using range and resize function. So let's start with the aggregate function sum. So the command is np.sum, then open the parenthesis and I'm giving the NumPy array. So what is the output? It will give the out, it will sum all the numbers, add all the elements inside the number array, give a single output. So that is a sum element. It's a very straightforward. The second is, suppose I want to add in row wise. That means 1 plus 2 plus 3. And then I want to add 4 plus 5 plus 6 in the row wise. Or I want to add only in the column wise 1 and 4, 2 and 5, 3 and 6. In that case, the command is np.sum, the same thing, but an input. Then we will give the direction we want to sum. For example, I am giving axis equals 0. So let's see what is the output. So the output is nothing but axis is 0, means it's in the column wise in this direction. That means 4 plus 1, 5, we got 5. Then 2 plus 5, 7, we got in column wise it add and we get the output. Suppose instead of axis of 0, we are giving np dot sum, again a, comma, axis equals, instead of 0 we are giving 1. So what will happen? It will add in row wise. That means 1 plus 2 plus 3, the output is 6, and 4 plus 5 plus 6, in the second row the output is 15, and the output will be in the form of array. So that is the sum and in the direction. Also we can do the sum in a different command, a dot sum, and we can give the array, sorry, a dot sum, and here the axis, or we can just simply use this function also, but better not to confuse with too many functions, similar functions. Instead of stick with only single function, single type of functions, which will avoid the confusion. The next is that the product means now a dot, sorry, a dot product, instead of np dot prod and a. So it will give the product of all the numbers here, similar to the sum. So if I want in a certain axis, we can again do np dot product a and axis equals 0. That means in oh, np dot pro number has no attribute prod. Sorry, it's not b, it's d. So it will give in a column wise product. That means 1 multiplied by 4, 4, and 2 by 5 is 10, like that. And if I am giving instead of 0, if I am giving the axis 1, it will do the product in row wise. 1 multiplied by 2 by 3, that is 6, and 4 by 5 by 6 is 120. So that is all about product and in axis, and we can get the maximum. So np dot max, the function is max, and we are giving the array. So the maximum value in this array is 6. So we got the maximum value. Similarly, we can get the minimum also. np dot minimum, and again passing the array, we got the minimum. Minimum is 1. And again here also we can use the aggregate element. So that means axis equals 0. That means we will get in column wise the maximum. So it is comparing in the each column what is the maximum value. So minimum value, sorry. So in this column 1 is the minimum value, in the second column 2 is the minimum value, in the third column 3 is the minimum value. Similarly, if I want to in row wise, so np dot minimum axis equal to 1. So in most of the aggregate element we can use the axis also to get in the certain direction like column or row wise. So that is about min and maximum. And also we can get the average of all these numbers. So np.avg and passing the numpy array. So oops, ave rag, the whole thing we need to type. So average is 3.5. That is the average of whole number. Suppose I want to get the average in this direction in row wise. So what we'll do, axis equals, or we can say column wise, equal to 0. So I get in column wise average. So 1 plus 4 is 5. 5 average of this is 2.5. The next is 3.5 and 4.5. Suppose I want the average in row wise. Row wise means again the same function average and axis equal to 1. So in the row wise we will get the average. So the next is that medium. We can get the medium as well. The same function np dot median and a. Again, you can combine the axis also in this. Next, we will discuss about the aggregate functions with multiple arrays. So for that, I have created another array B with a random function. If you are checking the values of B, it gives 0, 3, 0, 3, 3, 4. That is nothing but random numbers between 0 and 10. So the first few examples is maximum minimum. So the comment is np.max a comma B. So what it is actually giving, it will compare each element with its respective position in the other matrix. That means 0 here and 1 here, and 3 this one here, second element here, and the second element in that row here, 4. Then this 3 with this 5, and it will give an output of maximum among these two. So in this maximum, 1 and 0, 1 is maximum, 4 and 3, 4 is maximum. So if you are seeing the last element 6 and 4, 6 is the maximum. Similarly, we can get the minimum also, np dot minimum a comma b. So it will give the minimum values. Also, one more thing we need to notice that np.max, it is only for one matrix. If you are giving passing two matrices in that, a comma b, it will give an error. This only take the output one. Sorry, the input is one. One matrix only we can check with this command max. But if you want to check two elements, then we can use maximum function. Not only two, we can have more than two elements. Suppose I am creating a third matrix here, like C and random matrix C here, and if I'm checking A, B and C here, C is this one, B is this one, and A. So we have three matrix here, and I can pass, instead of two, I can pass all the three matrix. So it will compare the three matrix and give the output. So the third one, 3, 2, 3. So the first one is 1. The A also we need to take A. So A is 1, 3, and 0. So what is the maximum? The first element from A, first element from B, and first element from C. The maximum is 3. So the output will be 3 here. And then the second element, that is 2, 1, and 2. So 2 is the maximum. And if you're seeing the last element, 6, 6, and 5. So 6 is the maximum. So it will compare multiple elements, not only 2 or 3. We can give n number of arrays in that. And this is one of the example, few of the example for multiple aggregate functions with multiple arrays. Next, we will see some of the statistical the aggregate function. That is, I am leaving it to explore for you. It is one of this correlation function, correlation coefficient, that is np dot correlation coefficient, and argmax and percentile. Cumulative product, cumulative sum, standard deviation, and variance. These are some of the generic, very basic statistical aggregate functions. So I request you to explore that more into that. And there are more. It is, everything is straightforward. Only thing you need to understand what the function, how it works, or what exactly the meaning of that function. For example, what is the meaning of variance? What is standard deviation? So that's all about the basics of aggregate functions in NumPy.